My name is Kurt. I'm going to talk about using TypeScript to build better JavaScript applications. I want to talk a bit about what TypeScript is and why it may or may not be a tool you want to use in your toolbox. So I'm not a Microsoft employee. I'm not here to evangelize TypeScript, but I found it useful on some of the projects I've been on, and I wanted to share with folks what I found about its pros and cons. So who am I? I'm from here, Minneapolis, Minnesota. I've been developing web apps for over 12 years. I've used a variety of different languages over that time, but some of the things near and dear to my heart that I enjoy are Python and Angular, as well as C# and now TypeScript. So I've definitely gotten to see a few different technologies over that time. So what are we going to cover today? This is an important slide. I want to talk about what TypeScript is, a little bit about its syntax. I want to show you how you can get started if you're interested in playing around with TypeScript yourself. I'm going to compare it to some of the other tools and languages out there that will also compile into JavaScript, which is what TypeScript does. Talk a little bit about why you might want to use types. Types is something that's optional in TypeScript, but really if you don't want to leverage the types, TypeScript may not provide enough benefit for you to use it. So I want to talk about the advantages of having it. Finally, we'll cover working with JavaScript libraries, which is very easy in TypeScript. It's one of its advantages. And we'll show some of the tooling that exists for TypeScript apps, which I think is, well, again, one of the big benefits of it as a tool. So what is this thing called TypeScript? Well, right from the TypeScript website, TypeScript's a tool that lets you write JavaScript the way you really want to. It's a typed superset of JavaScript, which means you have all of the features of JavaScript plus some extras. And the way we're going to see this as it helps us is that TypeScript is JavaScript. So you can take a JavaScript file, you can pass it to the TypeScript compiler, and it will compile no problem. But it also adds things on top of it. Works in any browser. You don't have to have a TypeScript virtual machine or special support in your browser. The TypeScript compiler will output JavaScript code for you that works in all the major browsers. It's not limited to Internet Explorer or Chrome. You can also tell the TypeScript compiler to output it in ECMAScript 5 if you want, or ECMAScript 6 even. Works on any OS. All my demos are going to be on a Mac. I happen to like to use the IntelliJ tool suite, but you can also use Windows and Visual Studio if you like, or Linux. There's a Sublime plugin and Eclipse plugin, so you'll see it's available. And surprisingly, even though it's from Microsoft, it is indeed open source. So wait a second, Microsoft and open source, does that really work? It turns out that Microsoft's been under a little bit of a pressure in the developer world, and they've been moving all of their developer tools and products kind of towards an open source model. And TypeScript was put on GitHub pretty much right away. It started out on Codeplex and Microsoft side, and now it's on GitHub. But it's always been open source since it's been released. So anybody can contribute to it. It basically runs on top of the Node stack. The actual TypeScript compiler is leveraging Node. As you're going to see, you can install it through npm. It's just another tool in the JavaScript ecosystem. It's almost indistinguishable. So a little bit surprising. Not a lot of folks are aware of that. So, JavaScript is valid TypeScript. So this example here on the screen, you can see on the left-hand side, we have TypeScript code. And on the right-hand side, we have JavaScript code. And they're identical. So this exact TypeScript code translates to the exact same JavaScript code. Now, this admittedly is a pretty basic example, right? I don't usually write code like this. But the point is that you don't have to do anything to your current JavaScript code to make it work with TypeScript. And I think that's an important point to make. Now, since we're dealing with a compiler here, the TypeScript compiler takes your TypeScript file, compiles it, and spits out a JavaScript file. And you might wonder, well, what is it going to do to my code. They're probably not going to be able to read it. I'm probably not going to be able to understand the JavaScript that comes out. So what I did is I wrote a TypeScript class that's on the left-hand side, and I passed it through the TypeScript compiler, and it gave me the JavaScript that you see on the right-hand side. Now, for full disclosure, I did add a couple line breaks to the generated JavaScript because I wanted it to fit nicely on the slide, but very few line breaks were added. And I think you'll see that it's JavaScript that you would probably write by hand if you were doing it that way. Now, I myself, I freely admit, I'm not the best JavaScript developer, and I find that JavaScript's lack of a true class construct holds me back. If you're one of those folks that likes JavaScript just the way it is now, today, you like the prototypical inheritance, you like working with that, you like using the module reviewing pattern, then TypeScript might not be the best for you because you're already doing this in your JavaScript code. But I didn't really want to have to deal with that. I didn't want to have to show my junior developers how to do that and try to enforce that structure. I wanted the tool to help, and that's where TypeScript really made a big difference for me. But I was impressed with how readable the JavaScript was that came out. And I think that helps a lot when you get to debugging, although, as we're going to see, source maps are supported, so it's not like you have to dig in the generated JavaScript, but it made me feel better knowing that I could read the JavaScript that was coming out of it, should I encounter some issue. Alright, so what are some features of TypeScript? Probably the biggest for me was the ability to do classes right out of the box. And TypeScript targets ECMAScript 6. So it has features in it that are going to be in ECMAScript 6. But you can use them today in TypeScript. And that is a powerful capability. We get classes, we get modules. Those are both part of ECMAScript 6. It's kind of giving us the future now. If you use TypeScript, you're getting those features now. You can use them. You don't have to worry about the browser supporting ECMAScript 6 because the TypeScript compiler is going to take care of that for you. Interfaces, this kind of gets into the whole typed nature, which is optional in TypeScript, but it is a feature of TypeScript. You can have interfaces. Generics, again, another one of those features that probably only matters to you if you like that typed aspect. Arrow functions, these are just functions, function pointers, functions that you can pass around. They have a special syntax you can use that I believe, again, is similar to what is going to be available in ECMAScript 6 for quickly defining a function inline. That's what arrow functions are. I actually don't have an example of that on the screen, unfortunately. These other features I have examples of. References. So what I mean by references is that comment that you see on line 1 in the code sample, where I'm basically referencing another TypeScript file that has a list of all my other TypeScript files essentially in my project. And what the references do is they help the TypeScript compiler know what all the classes and modules are in your application. And there's actually a tool that you can use that will make this _all.js file, you can actually call it whatever you want, that has kind of all your TypeScript code in there. Or if you want, you can treat it more like an import statement and just import the specific TypeScript modules or files that you want to make available to this particular class, or file in this case. And finally, type definitions. So what I mean here by the type definitions, you're going to see an example in a moment, is let's say you have an existing JavaScript library that you would like to call from TypeScript, totally possible. But if you want to get all of the nice typed data, you want to know what functions and methods available and what types that JavaScript library deals with, you can write a type definition file. We'll see an example of it. That just merely tells the TypeScript compiler, here are the types, here are the functions that are available as part of this JavaScript library. You don't have to rewrite the JavaScript library, you just have to write this definition file. And you also can skip that in the definition file. You just won't get the typing benefits of TypeScript. Finally, like other things in TypeScript, TypeScript tends to smooth over some of those rough parts of the JavaScript language. So it includes a better handling of the this keyword by default. Right out of the box, you get that with TypeScript without having to worry about it. I think the best way to think about it is that this keyword works in a way that you would expect coming from another language. So rather than have to worry about what this is pointing to, which you sometimes have to do in vanilla JavaScript, it works the way that you would expect it.
So your example would be in that then callback with this would automatically be one from calling.
Yes. Yes. I believe that's how it works. Yep.
So is there a way to modify that behavior?
That's an interesting question. I don't know the answer to that. That's something you can turn off and on.
So when ES6 single negative action, that's cool. So I'm curious if maybe that's what TypeScript is going as well. So if you function in graphic JavaScript,
right?
You get.
Oh, okay. Yeah. So I'm not familiar with that particular one, so I don't know the answer. I don't want to give a bad info out either. Yep.
Well, in my experience using TypeScript, it's kind of like you're describing, like right there you're defining what's like a member function there. So this would be always referring to the object, but if you were to define it as kind of along the expression syntax, that's what this would refer to.
So this is in the lambda expression. So this would, right? This is here lambda. Right. So this would be the existing JavaScript.
Yeah.
No, that's
Yeah, it's not an arrow function. I'm actually using the regular function syntax here. So that means this is referring to my team's variable right here. So it's referring to the class right here.
So if you made that the arrow function, it would refer to the regular.
That's what it sounds like. Yeah.
ES6 or ES6 is the other way.
Okay. That's good enough. Yeah, no problem. Yep. Trying to figure out what it's doing. It's great. These are all great questions. Any other questions about features? Let's talk about some pros and cons. We may have found a new con, maybe. So pros. Now, you can take all these with a grain of salt. This is my perspective on the pros and cons. You guys may feel differently. That's okay. I like how the syntax for TypeScript is very similar to JavaScript. Right? I'm not learning about white space being significant or something. It's still the brackets. It's still the parentheses that I'm used to. It feels natural, right? It feels very natural. I really like that TypeScript targets ECMAScript 6. So it gives me the ability to use some of the nice things that are coming in ECMAScript 6 without having to wait 5 years for them to be ratified and actually appear in all the browsers that I support. I want these features now. I kind of want them now. I like the fact that the types are optional in TypeScript. So I like to be able to use the types when I want to use them and have it be optional in cases where I don't want to use them, where it doesn't make sense. Finally, I like the fact that classes and generics and interfaces are part of the language. That's actually something I do want to use as a developer. I realize that's not the case for everyone, but I do like using them. I like that it fixes this handling and smooths over some of those rough edges in JavaScript. Now, disadvantages, cons. It introduces a compile step in your coding process. So it's not really a showstopper, but it's another tool you have to set up, another step you have to be aware of in your process. So it doesn't necessarily come for free, right? You have to pass the stuff through a compiler. So along with that, it makes things like debugging, again, have to go through another step in the process. So you can use source maps with TypeScript, and I must admit, the first time I tried this, I thought it wasn't going to work, and I thought I was going to need to set breakpoints within the generated JavaScript inside Chrome, and I was just going to have to deal with it. And I turned the source maps feature on. I set my breakpoint in my TypeScript code in Chrome Developer Tools, and it worked. I didn't think it was going to, but it worked. So, there's times where you actually amazed when the technology actually works, and that was one of them. So, I put debugging on here because I think it's something you have to be aware of, and you have to configure to use source maps, and who knows, maybe there's some nuances in there that I haven't run into yet that could make debugging a problem, but it's there. Finally, TypeScript is another language, and it's another tool that you have to learn. There's so many front-end development tools out there now, so many JavaScript libraries, tools, and frameworks. This is another one, and it is something more to learn if you choose to adopt it. So you do have to weigh those pros and cons. I think if you're working in a larger team and a team that has a mix of different levels of JavaScript developers, having a tool like TypeScript that potentially provides a little bit more structure has some benefits to that learning curve. Got a question here in the front?
Yep. Have you seen anything? I was thinking about how funny this could be compared, instance and an instance and all this and that. Have you seen anything goofy, anything weird? What does it decide to do as far as But it's not like me or self or that.
No, you just use this. I mean, you literally use the this keyword, and it seems to behave in the way that I would expect. And I didn't put a lot of examples of that to do the nesting and kind of show you how it handles that.
How does it convert? Have you seen like when you take the TypeScript and you say this and it's this?
Yeah, I see what you're saying. Yeah, in the compile.
What is it?
Yeah.
It's underscore this.
Yeah.
Or those are underscore this equals. So I was just going through that. Actually, when you're using a function or callback, it is preserving the JavaScript syntax.
Okay.
And you have to use a TypeScript specific double arrow, like double shovel type syntax, which is the TS6 to get
the better behavior.
Better behavior. In this case, it would be
single, right?
Single dash.
Yeah. So sorry I didn't get a chance to bring a good example of that. One resource I would point out is if you go out to the TypeScript site, typescriptlang.org, they have a little tool where you can just paste in or type in some JavaScript, and it will, TypeScript, I guess, and it will show you the compiled JavaScript, again, side by side. And so you could do some experiments in there if you were curious on how that behavior worked. Plus, they have good documentation on that site that would describe the use of the this keyword in probably much more sufficient way than me up here trying to do it on the fly. These are great questions, though. Thank you. Okay, some quick comparisons. TypeScript, like CoffeeScript and Dart, is compiled. So you run the compiler over it, and you usually produce JavaScript with all three of these tools. Dart is somewhat unique in that Google has built a Dart VM that may someday, maybe it's already in Chrome, I haven't paid that attention, I admit, that could someday be inside the browser. But it seems like most people with these three tools use the compiler to produce JavaScript that will run in all the browsers. Now, in my research, I found that from a typed perspective, it really was Dart and TypeScript. Now, you can use classes with CoffeeScript, but it didn't seem to, be compiling and enforcing things quite the same way that Dart and TypeScript were. I must admit I'm not an expert in CoffeeScript and Dart, so you guys might have to correct me if I have something wrong on this chart. But that's kind of what I found when I was playing around with the different ones. CoffeeScript was unique in that out of these three, it had used whitespace to do some of its language constructs. So I'd say its syntax was quite a bit different than the other two. I don't have a feeling either way if it's bad or not, it's just different. So I felt like TypeScript and Dart offered a more JavaScript-like syntax approach. You actually had the brackets, and you'd feel maybe a little bit more at home as a JavaScript developer with either of those two tools. Now, I put 1 out of 2 under Dart because you have to do some extra steps, I found, if you want to use a JavaScript library with Dart. And they were steps that you didn't really have to do with TypeScript because of some of the differences. So, just something to be aware of. All three of these offer classes, which is a big reason why I started using them, because I missed that out of vanilla JavaScript. And again, I thought that TypeScript and CoffeeScript offered easier, quicker ways to use existing JavaScript libraries versus, say, Dart. It seemed to be more about, hey, use the Dart libraries, and if you need to bring in your own library, you gotta go through some steps to do that. So why would you want these types that TypeScript provides? I kind of alluded to it earlier, but I think having the types can help with large code bases and/or teams. This is just born out of personal experience. Again, it might not apply to everyone. I like the fact that types allow me to catch some errors quicker. Right during the compile step, compiler could pop up some warnings to me, let me know that there were some mistakes in my code. I like that I could produce a set of TypeScript code that provided a well-structured API, and my other developers could use that, and they could see the types, they could see the methods that were available, what arguments were. I also liked how when I was using Angular and learning Angular, I got a lot of good code hinting in the tooling because it was giving me typed information about what I could call in the Angular API, what arguments and what types those arguments were. It helped me learn and produce code that was calling the Angular API a lot easier, a lot quicker. And of course, tied into all of this, the types provide that extra metadata to the tooling so that you can get good code completion and you can actually have really powerful refactoring support right in your IDE. So in my case, I was using IntelliJ IDEA along with WebStorm, and TypeScript was just a joy to use in there. Now, they also have a fantastic JavaScript editor too, so you could tell there was a lot of intelligence there in their JavaScript editor, but TypeScript, I felt, gave me better suggestions, better code completion, because it had that typed metadata that's just kind of built in. So I already talked a little bit about existing JavaScript libraries, but I'd like to go into a little bit more detail. There's a project out on GitHub called Definitely Typed, and it provides TypeScript definitions for tons of JavaScript libraries. All of the big ones are definitely in there: jQuery, Angular, Node, Ember, Backbone. There's PhilGap APIs in there. A lot of the big ones are out there. And you just go to definitelytype.org, and you can pull down any of them. And the other thing I liked was that you could write your own definitions easy. So if for some reason you're using a third-party JavaScript library like I'm going to show in a second, and you want to have TypeScript know about some of the types that library provides, it's easy to write one of these definition files. So I'll show that in a moment. Also, you could write your own definition if you had an internal API or JavaScript library that you built internally. You don't have to port it over to TypeScript, you could just write a definition for it. And it can continue to live as JavaScript, or maybe later you decide to convert it to TypeScript, either way. So what do these custom definitions look like? So I was using a service called Pusher to do essentially real-time notifications in my app, real-time messaging. And it operates over WebSockets and has a fallback that I think uses Flash or something. But I didn't really want to deal with WebSockets and have to worry about them, so I use this Pusher library. And they have a JavaScript file which you can reference. It's hosted on a CDN to use their service with. But I wanted to call it for my TypeScript code, and I wanted to make sure I was using the right type, so I decided to write a custom definition. Now, admittedly, their API, or the piece of their API I'm using, is very small. It's not very large, but I thought I made a good example here. So you simply say declare class, and I called it Pusher, since that's what you use in their API nomenclature, and I said that class had a constructor that takes a string, and it has a method on it called subscribe that takes in a channel name that's a string, and it returns a channel. And then I set channel up as an interface, and I said that it had a bind method, again with a string and a callback function as part of it. And then below at the bottom of my screen, you can see the code that I was using to actually interact with the Pusher API. I queued up a new instance. I did remove my key from the screenshot, my API key. And then I created a channel by calling subscribe. And then I called the bind method and passed in my function. So, I think for the most part, it looks pretty straightforward, like you'd see in a lot of other JavaScript libraries. And I like the fact that it was easy to write one of these custom definitions. So. All right, so getting started. So if you want to get started with TypeScript, here's a couple quick commands to get you going. First is to install TypeScript from npm. The second is to compile it. And the compile command I've got here will produce not only a JavaScript file, but also a source map, which I found works great in the current dev tools. And my approach for compiling has been to create this _all TS file that has references to all the TypeScript files I want to compile, and tell the TypeScript compiler to take all my TypeScript files and compile them down to one JavaScript file. So essentially, as part of the compile, I'm concatenating things together. So I don't really have to worry about the concatenation step. So then I end up with a application.js file that has all of my compiled TypeScript code in JavaScript in it, and you can open it up and look through it. Now, if I wanted to, I could pass that application.js file out to a tool that does minification or obfuscation of the JavaScript code if I wanted to. That would be another step in that build process. Now, there's other parameters you can pass to the TypeScript compile command. I'll let you guys look those up if you're interested. These were the most common ones that I found myself using. So tooling, there is a Grunt plugin called Grunt TS that I recommend. There's actually two. There's also a Grunt-TypeScript, but Grunt-TS offers the best features. It has a lot more than the other one. So I've been using that. That's been very helpful. And then I personally myself find the IDEs useful to use with TypeScript. So these are things like WebStorm, IntelliJ, Visual Studio, Eclipse. A lot of folks are surprised when I tell them that I write TypeScript using IntelliJ. They're like, oh, I thought it would only work in Visual Studio. It's not true at all. In fact, the TypeScript team, one of the things they open sourced was settings for Sublime. So a package, for Sublime for TypeScript support. And then IntelliJ obviously has one for their products. I believe there's an Eclipse plugin as well. I haven't used it, so I don't know how good it is. But I know TypeScript works well in Sublime and Atom because I've used those two. Now they're editors, so you don't get quite as much tooling as you get with the IDEs. I don't think the editors have refactoring tools. You would kind of be on your own for that. But they'll interact with the compiler, give you code, nice code formatting, maybe some hinting. But if you really want to take advantage of the tooling, your best bet is to use an IDE. I wanted to show quickly just a little bit of a demo of what the tooling looks like in IntelliJ, since that's kind of a big part of TypeScript is taking advantage of this tooling. Alright, so here I have a grunt file that I set up, and I'm just using the watch command to run the TypeScript compiler every time one of my TypeScript classes gets changed. And I can either have grunt watch running, or in IntelliJ I can set up a file watcher that essentially does the same thing. Either way, I kind of like going with the grunt approach, which just feels more portable. If I can, I have an AngularJS controller here that I wrote as a TypeScript class. It's quite lengthy. But I can go in here and I can introduce an error. and you'll see the editor is kind of alerting me, hey, that might not be right, and I can actually trigger the TypeScript compiler here. And it will actually pop up an error once it sees that. So the other thing I can do is I can go down here to one of my methods, and I can go to refactor, and I can change the name of it, and sure enough it'll go through and preview and show me where potentially in my code it needs to make that change, and if I think it looks good I can tell it go forth and make all the changes for me. I'm done. So kind of a nice handy feature if you want to be able to have those refactoring capabilities. Oh, yeah. Mm-hmm.
How is that debugging when you're going to do that?
Yeah.
When I've used stuff like TypeScript, it's hard to, at least on the server, it's hard to separate.
Yeah.
Stuff like that. Getting out of
Yeah, great. Yeah, let me see. I can actually, let's go ahead and show that right now. So I have a fantasy football draft system here is what I've been building. My friends and I use this to draft every year. And I actually, yeah, it already has a problem. Okay, so I've got, yeah, well, this is also the test database, so no real draft data is displayed. So what you can do is I've got my draft controller here, and this is a TypeScript file, TS file here, and I can go in here and I can set a breakpoint. And here you can see the debugger has paused. I'm at my breakpoint. This is in the TypeScript code, and now I've got the local variables. I can see what's available in here, and I can browse and I can step through the code just like I can using JavaScript. And the key thing that you have to do to enable this is you have to have your TypeScript compiler set to produce the source maps. So you can see here what it's doing is not only is it producing a player service.js file, that's the TypeScript compiler, but also it's producing the source map. So if you have that and Chrome can see those source maps, then I believe you can do debugging right in the Chrome DevTools. And it's pretty easy, pretty seamless. I was shocked when that worked because I thought that I was probably going to be missing something and it wasn't just going to work. But that one definitely passed the 5-minute test. Let's see, what else do I want to say about debugging? You could, I haven't had to do this, but I guess if you had to, you could go into your JavaScript file here and potentially debug right inside here. And you'd have to kind of know how that maps back to TypeScript. Sometimes, I don't know, maybe for some folks that might be easier because they're closer to JavaScript. For me, it was just better to set the breakpoints right in the TypeScript file. So making my app better. So you saw a little bit of from the fantasy football system, even if some of the data in it was a bit flawed. What I did is it gradually kind of moved my code that had been JavaScript, and admittedly probably not the best written JavaScript. I gradually moved it over to TypeScript. So I didn't just stop the presses and spend a bunch of time converting it all over to TypeScript. I actually kind of did it sort of piece by piece along the way, and there wasn't a problem. It's an Angular app, and I was able to just take parts of it and move them into TypeScript. So I started with the services in my app, the layer that talks to my server. I started there and built out TypeScript classes first for those remote things, because that was the thing that I struggled to structure real well in my app, just using plain JavaScript. And I found that as I did that, I was adding types, and I could see better what methods were available in my services, and it was easier for me to update the controller to call those methods in the service. So Admittedly, this is a smaller app, it's not huge, but I did see that benefit. I appreciated that. And then I really made working and learning Angular's API a lot easier. I wasn't really familiar with, what methods you can call on the HTTP service or the location service. And when I started to build out the controller in TypeScript, there's a great type definition out there for Angular. So the tooling was telling me exactly what methods I had available for those different Angular services. And then if I had a question, I could jump much more quickly to the right method in the documentation to figure out what I needed to do. So it seemed to make things easier to have some of that typing metadata there. Again, probably not a must-have for everybody, but I thought that it was a nice to have, a nice addition. Made my life easy. So, some key points. JavaScript is valid TypeScript. If you want to take one thing away from the presentation, let's let that be it. TypeScript is following the ECMAScript 6 standards. I think that's really wise of them to do that. Give us some of those features now. Types are optional. You don't have to put the types in the TypeScript code. You can put the any type, or you can just leave out the type entirely. TypeScript doesn't force you to do classes and interfaces, although I must admit, you probably will. I don't know how much you'll gain from using it if that's not something that you want. Finally, I like the fact that there's a lot of refactoring capabilities when you use TypeScript, that you can leverage the tools, the IDEs. That just happens to be how I like to work. Might not be for everybody, but that was a big boost for me, a big thing that I like about the tool. I've got some references in here. I don't expect you to be able to copy these down. My slide deck will be out on the site. You can click on these. They're just some examples that walk you through getting started with TypeScript, using it to talk to some remote services is the last link. So kind of get you going, and it'll get you in the TypeScript community where you can find more articles. So finally, at this point, I'd like to pause and take any questions folks have. You guys have been great. You've been asking questions during the presentation, which I like as well. So good. Is anybody here thinking of giving TypeScript a try? Got a few folks. All right. Who's used it already?
In future version, because they adopted ES6 features before they became standard.
Right, yeah.
And then the TypeScript guys basically provided feedback. The ES6 guys were like, oh, hey, we should change this.
Ah, okay.
TypeScript has things that are worth meeting a lot.
Gotcha.
It's a feature one time when
they can come better along.
The type stuff is definitely something that's lacking in JavaScript, so it's very good.
Cool. Yeah, that's great feedback. I must admit, when I decided to give the presentation when I proposed it, I didn't think it would be accepted. I didn't know, what a conference devoted to JavaScript would think of a tool like TypeScript. So I'm interested to hear your guys' feedback. And
a couple of friends that program about that, and this is good because they're used to programming sort of structure, right? So now, and they're all being kind of forced to, some of them started migrate towards client side. So those guys is going to be forced to work, this is perfect.
Yeah, it's a good fit to help get them from the C# world into being able to produce something in JavaScript, essentially. I've heard the same thing with some teams of Java developers too, that structure was familiar to them, and they could finally produce some good JavaScript code.
Yeah, that's what we're finding. We have a lot of good JavaScript.
Yeah.
Using this to try to
Yeah, that's great. That's great to hear. I think there's a question there.
whether is that demo app up on GitHub?
Not yet, but it will be soon. So if for some reason you don't see it and you want to get it before I get it up there, just drop me an email. My email's right up on the screen here, and I will send you a copy. The reason it's not up there right now is I have a bunch of API keys and my login credentials. I have part of the app downloads the player data from the Yahoo API, and I just haven't had time to pull out those secrets. Cool. Well, thanks, guys. If you have any other questions, feel free to find me today or right after this presentation. Thanks.